Greetings and salutations to all of you, including the haters. Welcome to my channel. My name is Oscar Perez. I am a movement specialist, coach, and the founder of Primal Kinetics training system. I provide online coaching services for training as well as in person. My contact information will be provided and found in this video's box. In this video of the series My Beef with Veganism, I'm going to talk about minerals and trace minerals. Before I jump into the meat of this video, I want to thank Rob Tunks, who is a rancher down under in Australia, who also has a YouTube channel named Zap Puppy, for being the very first and so far the only monetary supporter of my channel. You have probably seen him or heard about him before. He's been featured in Bobby's Perspective YouTube channel in a couple of his videos. By all means, please go ahead and subscribe to his channel. He's a really good guy. And say hello for me. Minerals and trace minerals are inorganic elements found in both plant and animal sourced foods. As elements, they hold their chemical structure after being consumed, unlike vitamins. To our knowledge, there are 16 essential minerals that we need in our diet, and they are calcium, phosphorus, potassium, sulfur, sodium, chloride, heme iron, magnesium, zinc, copper, iodine, manganese, selenium, molybdenum, chromium, and fluoride. These minerals play important roles in basically every function of our bodies. They help regulate blood pressure and fluid balances. They keep muscles and nerve cells firing. They deliver oxygen and facilitate cell growth and replication. As with vitamins, mineral deficiencies and toxicities can occur if intake is inadequate or in excess. I strongly believe that once the majority of the population, or even better, the entire human race, comes to terms with the fact that we thrive on animal-sourced foods, it will be beneficial for the planet as a whole. All essential minerals can be found in both plant-sourced foods and animal-sourced foods. But there is a stark difference in absorption of these micronutrients. The bioavailability of the animal-based micronutrients is much higher, and they do not come with the pre-packed anti-nutrient content in plant-based foods that most humans cannot process, thus harming our health. Iron deficiency is very common, and since this micronutrient plays a vital role in carrying oxygen to cells throughout the body, being deficient leads to fatigue, weakness, pallor, and anemia. Plant-based dieters might say, well, I'll just take an iron supplement. My answer to that is, why do you have to spend more money in synthetic or man-made supplements if you already have and know where to find it in the natural world? Besides, every micronutrient, like I have said before, needs to work in conjunction with other micronutrients like vitamins and other minerals in order to be absorbed efficiently. For example, rich containing foods of iron, specifically heme iron, also contain other micronutrients that are essential for human health, such as K2, D3, cholesterol, DHA, EPA, retinol, etc. These nutrients work synergistically with each other. If any of them is lacking in our diet, our bodies will start to suffer the negative consequences. Memory and cognitive problems are common symptoms when iron levels are low. Two kinds of iron exist: non-heme or inorganic iron, which is the one found in plants, heme iron or organic iron, which is the one found in animal-sourced foods. The inorganic iron is at least 3 times less bioavailable than heme iron, and as you know, plant-sourced foods or just straight plants contain anti-nutrients, which affect negatively omnivores and carnivores. They inhibit the absorption of numerous minerals, including iron. A video about anti-nutrients is on deck, by the way. There are studies that show that vegetarians often have a similar intake of iron to omnivores, and yet they suffer a higher degree of iron deficiency. Many people choose a plant-based diet because they are under the impression, or in other words, indoctrinated, that this diet is good for their health from a nutritional perspective. It has been more than 50 years of being told that meat, eggs, and animal fats are harmful for humans, and that in contrast, we will live longer and enjoy superior health if we minimize or even avoid their consumption completely. Most people know that calcium is important for bone health, but not many know that this mineral is essential for muscle and nerve function, and that is also involved in blood clotting. The bioavailability of calcium from plant foods is affected by their levels of oxalate and phytate. These two are anti-nutrients, which are inhibitors of calcium absorption and thus decrease the amount of this mineral the body can extract from these foods. Other than this, high oxalate diets have been linked to an increased risk of kidney stones and other health problems. Normally, calcium and small amounts of oxalate are present in the urinary tract at the same time, but they remain dissolved, causing no issues. However, sometimes they bind to form crystals, and in some people, these crystals can lead to the formation of stones, especially when oxalic acid is high and urine volume is low. Small stones are not much of a concern, but the same cannot be said about large stones because they cause severe pain, nausea, and blood in the urine as they move through the urinary tract. About 80% are composed of calcium oxalate. A study published in 2009, which was led by Tuan Nguyen, discovered that vegetarians had 5% and vegans 6% less dense bones than meat eaters. It is worth noting that without an adequate intake of vitamin D3 and rich cholesterol foods, the consumption of calcium-rich foods will not matter much, simply because calcium requires D3 for its absorption. For better understanding, just take a look at this diagram. Zinc. Zinc is a trace mineral abundantly distributed throughout all body tissues and fluids, and second only to iron amongst trace elements in the body. It is essential for multiple aspects of metabolism, including catalytic, structural, and regulatory functions, and also plays a role in the immune system. Zinc is a catalyst for a large number of metabolic enzymes. It helps maintain structural integrity of some proteins and can play a role in the regulation of gene expression. 60% of total body zinc content is in the skeletal muscle and 30% is in bone mass, with plasma zinc representing less than 1%. High concentrations of zinc is found in the choroid of the eye and in prostatic fluids. In blood plasma, zinc is bound to and transported by albumin and transferrin. Bioavailability also plays an important role here. Many plant foods that contain zinc also contain phytate, which inhibits zinc absorption. Vegetarian diets tend to reduce its absorption by about 35% compared to omnivorous diets. One study suggested that vegetarians may require up to 50% more zinc than omnivores for this reason. A meta-analysis of 34 studies found that both zinc intakes and serum zinc concentrations were lower in vegetarians than non-vegetarians. The inhibitory effects can be overcome by food processing techniques that use enzymes or thermal processing to hydrolyze phytic acid or other anti-nutrients. Fermentation and cooking are amongst these techniques, as well as sprouting and leavening. Because of modern processing methods and the wide variety of plant-derived foods rich in zinc, its deficiency is less likely to be a problem in first world countries or regions, but that cannot be said for developing countries or for the poor. Higher levels of dietary protein enhance zinc absorption, as zinc binds to protein molecules, except when there is too much casein, which is in cow's milk. This, although, can be fixed by fermentation, so yogurt, cheese, and or butter are a great alternative if you love dairy. But if you are allergic to cow's milk, then your best alternative is to bind goat or sheep milk, because it is more compatible for humans. The effects of mild or marginal zinc deficiency are reduced growth rate, reduced immunity, increased susceptibility to infection, impaired taste acuity, and poor wound healing. The reasons for primary zinc deficiency include poor dietary bioavailability or high physiological demand during infancy, childhood, pregnancy, and lactation. The effects of zinc deficiency can be particularly apparent during periods of rapid growth and development, such as infancy and adolescence. Iodine is an essential element needed for life. It is best known for the vital role it plays in thyroid hormone production in humans as well as in all vertebrates. The body does not make iodine, so it is necessary to incorporate foods rich in iodine in our diet. Approximately 30% of the world's population remains at risk for iodine deficiency. A lack of iodine can cause the thyroid gland to swell in an attempt to increase the absorption of iodine from the blood. Swelling in front of the neck is the most common symptom of iodine deficiency. This is called a goiter, and it occurs when the thyroid gland grows too big. Another instrumental function of iodine in our bodies is in brain development. An inadequate amount of iodine leads to retardation. Infants, in fact, may face lethal consequences if their mothers are severely deficient in iodine. A research conducted at Arizona State University has linked iodine deficiency in mothers to autism in their offsprings. The thyroid gland creates hormones to regulate metabolism and cellular function. Low iodine levels may slow our metabolism because thyroid hormones control the speed of it, which is the process by which our bodies convert the food we eat into energy and heat, causing undesirable weight gain. This in turn results in fatigue because our bodies cannot make enough energy as it usually does. Some studies have found that nearly 80% of people with low thyroid hormone levels feel tired, sluggish, and weak. Other negative consequences from a malfunctioning thyroid are hair loss, dry and flaky skin, feeling colder than usual, changes in heart rate, trouble learning and remembering, heavy or irregular periods. The common saying, too much of a good thing, does have relevance in nutrition. The body prefers and relies on a happy, balanced medium, and too little or too much of any essential vitamin and or mineral can lead to imbalances and health problems. Many nutrients also work as antagonists with one another, which can mean that when one is too high, it causes the other to become too low. These nutrients also work synergistically with each other, Having an imbalance of a nutrient can cause absorption issues with other nutrients. All of this could and will increase susceptibilities to certain acute or chronic conditions. A very good example of antagonistic behavior in our bodies is what happens between zinc and copper. There are more than 3,000, you heard correctly, 3,000 zinc proteins in the human body, some of which are key enzymes, and some whose functions are currently unknown. Zinc ions also work as signalers in the body. The body requires specific cellular concentrations of this mineral to ensure the zinc reactions can take place without disrupting the work of other essential ions. In the cell itself, zinc is incorporated as a cofactor more often than many other essential vitamins, and the concentration is almost as high as that of ATP, which is the energy of the cell. Copper also plays a role as a cofactor and enzymes or other functions in several biochemical processes, including redox reactions, iron metabolism, antioxidant defense, immune function, and neuropeptide synthesis. Copper deficiency is rare. It can lead to issues with the development and formation of the skeletal system, the cardiovascular system, the immune system, and the neurological system in fetuses. Chronic insufficiency might lead to issues with cholesterol metabolism. Anemia, impaired growth, neurological symptoms, osteoporosis, and bone development abnormalities are also signs of copper deficiency. Despite its importance, copper has the potential to be toxic at high doses. High levels of copper can contribute to excessive oxidative stress, which can damage the cell and cause it to die. It can also lead to an increased risk of heart disease and cognitive decline when there is too much copper in our bodies. Copper and zinc are antagonists, which means they work against one another and compete for binding sites. Excess zinc can lead to copper deficiency and vice versa. A study in the 1990s found a correlation between oxidative stress and the copper to zinc ratio, independent of health status, age, and gender. However, the older participants did have a higher level of oxidative stress and a higher copper to zinc ratio. In the healthy elderly population, the higher ratio was a result of higher levels of zinc, whilst in those who were disabled, this was because of a lower level of zinc and high levels of copper. In fact, the copper to zinc ratio might just be a marker for inflammation that predicts all-cause mortality, at least in the elderly. Higher ratios were associated with low serum albumin, high CRP and ESR levels, and high IL-6, all markers for inflammation. Question: does the imbalance of the copper to zinc ratio lead to inflammation and oxidative stress, or is it the other way? One study points to inflammation and oxidative stress influencing this ratio, generally through increasing copper levels and decreasing zinc levels. Impaired insulin balance and other hormone imbalances might also contribute to an increased copper to zinc ratio. Part of the normal immune response depletes infected tissue of zinc to starve the pathogens from this essential metal, whilst also moving zinc to other locations to support immune response. Copper increases to also assist in this response, as it has been known to regulate macrophage pathways. It is important to note that many of these changes are not related to nutritional or supplemental intake of these minerals. There are also many other ways in which this ratio affects health, one of them being our sleep patterns. Higher levels of copper correlates with a reduction in sleep duration. As you probably have figured, all the minerals and trace minerals are important for our health. but talking about all of them will make this video too long, and in turn you might lose interest in continuing watching it till the end. So I have to make an executive decision. I will talk about one more micronutrient before ending this video, and I hope you would not mind. Selenium is incorporated into selenoproteins that have a wide range of pleiotropic effects, ranging from antioxidant and anti-inflammatory effects to the production of active thyroid hormone. Low selenium status has been associated with increased risk of mortality, poor immune function, and cognitive decline. Higher selenium status or supplementation has antiviral effects, is essential for successful male and female reproduction, and reduces the risk of autoimmune thyroid disease. Glutathione peroxidase is an enzyme that requires selenium for proper function. This enzyme acts as a cellular protector against free radical oxidative damage. This enzyme is more effective than any other antioxidant out there, including vitamin C. As I like to say, do not mess with nature. Every micronutrient is found in perfect balance in good quality animal sourced food. Plant sourced foods are necessary for some. As long as you understand the importance of the bioavailability of the micronutrients and how to prepare your foods, you will not have problems. Keep it simple, guys. By just consuming nutrient-dense foods and a mix of land and sea. Thanks for watching and supporting my channel. Catch me on the next one. Goodbye.